Nanotechnology. You've probably heard about it in some form or another. It's appeared in many different forms across all types of culture and media. It's even gone so far as to cement itself as a sort of deus ex machina trope of science fiction. A number of different fantastical things likely come to mind when you think of nanotechnology, but what exactly is it as it applies in the real world, and how does it solve real-world issues? Well, let's dive into the magical world of science to find out. Okay, now play the intro. We roll the intro after I do. What? There's not enough room in the budget? Oh.
Well, first and foremost, nanotechnology is loosely defined as the manipulation of matter on an atomic and molecular scale. A more generalized definition is given by the National Nanotechnology Initiative, a federal government-funded program for the development of nanoscale projects, defining nanotech as the manipulation of matter with at least one dimension sized from 1 to 100 nanometers. This definition is meant to illustrate the quantum mechanical effects needed to be accounted for when dealing with nanotech, and, indeed, all forms of theory and research dealing with matter on this scale are included under the umbrella term of nanotechnology. Some examples include surface science, organic chemistry, molecular biology, semiconductor physics, and microfabrication, just to name a few, so nanotechnology really refers to a large subset of individual scientific studies.
The methods with which nanotechnology is implemented are as varied as the results one can obtain by using it. Nanomaterials, nanoelectronics, nanometrology, molecular nanotechnology, nanotoxicology, these are all just various subsets of the umbrella term known as nanotechnology. But for this particular video, we're only going to be focusing on one subset, and that's biomimetics.
Biomimetics is the study of natural nanoscale structures that exist in life forms. The intent here is to replicate these phenomena and utilize them in new and creative ways. Two subjects of biomimetic research are the tenebryonid beetle of the Namib Desert and the thorny devil of the Australian outback for their unique properties. Both creatures are able to survive in harsh, dry conditions by funneling water into their mouths from different parts of their bodies. It was found that the thorny devil had the ability to seemingly drink from its back legs. What was actually happening was that when the devil's back leg was immersed into water, the water would travel up its leg, across its back, and begin to flow into its mouth. With sufficient time, the thorny devil could perform the same feat on damp sand or soil, giving it an invaluable edge for surviving in a desert environment. Similarly, the tenebryonid beetle harvests dew from the morning fog by lifting its rear into the air, causing water to collect on hydrophilic sections of its body. As the water collects, it grows, beads, and flows down the hydrophobic channels into its mouth. It's due to the surface structure of these animals on a nanoscale that these phenomena take place. By understanding them, scientists are able to create certain nanomaterials which are able to be applied to surfaces, making them superhydrophobic. Likewise, the cowpea chloric mottle virus, a virus which specifically infects the black-eyed pea plant, is a promising subject of nanobiomimimetic research. The virus body itself is found to have unusual properties. At pH levels of above 6.5, pores on the surface of the virus dilate and begin to exchange material with its environment. It is speculated that, by controlling the pH of the solution in which the virus is placed, it can be used to pick up, transport, and deposit materials on a nanoscale. This has been just a very superficial covering of nanobiomimetics as a whole, but I hope that it's at least piqued your interest. I highly recommend further research and investigation as the topic is vast and its applications are interesting.